One way to study particle reactions is by conservation laws. So in particle interactions, we know that it should satisfy these basic conservation laws. So it should satisfy conservation of energy, of momentum, of angular momentum, of charge, and upon the study of particle interactions, scientists have discovered that there's actually more conservation laws needed to explain these particle interactions. So, for instance, say you have a reaction wherein you combine a proton and a neutron. So, this reaction conserves energy. So, this reaction produces one proton, and one antiproton. So this reaction conserves energy, momentum, angular momentum, and charge. But this hypothetical particle interaction is not observed to happen in nature. So scientists were left to wonder if there are more conservation laws that we must know in terms of particle interactions. So the first conservation law is conservation of baryon number. So a baryon number is simply the nucleon number. So all nucleons have a baryon number of +1. All antinucleons, which are antiprotons or antineutrons, they have a baryon number of -1. And all others, photons, mesons, electrons, all others aside from nucleons, they have a baryon number of 0. So let's see how the first reaction earlier violates the conservation of baryon number. So you have one proton and one neutron. So initially their baryon number is 2. And then after the interaction, it produces one proton, and one antiproton. So the baryon number in the final state is 1 plus 1 plus -1, which is 1. So we are left with an inequality 2. Baryon number 2b is unequal to 1. Hence, this interaction violates the conservation of baryon number. So let's have one other interaction wherein baryon number is conserved. So here we have two protons, and after the interaction, it produced a proton and an antiproton. So initially, they have a baryon number of 2, and after the reaction, the baryon number is conserved. And this type of interaction is allowed in nature.